Find the volume of the solid obtained by rotating the region bounded by y equals the quantity x minus 1 squared and y equals x plus 1. And this region will be rotated about the line y equals 4. First step in the process is to draw the graph. Let's take our two functions. Y equals the quantity x minus 1 squared and y equals x plus 1. One of the first things you could do is find out where they intersect. This is rotated about the line y equals 4. We want to find out where they intersect at. And so we set them equal to each other. So we have x minus 1 quantity squared is set equal to x plus 1. That's going to give x squared minus 2x plus 1 is equal to x plus 1. If we subtract the x over, we get x squared minus 3x, and then we subtract the 1 over, the constants go away. We factor out the x, and we end up with x times the quantity of x minus 3 equals 0. So either x is 0 or x is 3. Great. The first function we know is a parabola, but we can even say more about it. It's a parabola that's obtained from shifting the standard y equals x squared parabola. It's been shifted 1 unit to the right. This minus 1 inside with the x gives you that. So we can draw that. Parabola shifted 1 unit to the right. Y equals x squared shifted 1 unit to the right. And the other function, that's a line with a slope of 1 and an intercept of 1, a y-intercept of 1. So they happen to intersect the y-axis at 1. They both do. The line would be graphed like that. And we know they also intersect at 3. And when x is 3 into either equation, you'll find that y is 4. Great, because then if we're going to be rotated about the line y equals 4, we can draw that in too. Okay, good. We have a good drawing of the graph. Now we need to move on to step 2. We need to decide which method to use. Let's put 2 of the same drawings. And the way you decide is by setting up, or going through the beginning process of setting up both. So with one, you want to draw a rectangle that is parallel to the axis of rotation. And with the other, you want to draw a rectangle that is perpendicular to the axis of rotation. When you're parallel to the axis of rotation, you'll be doing shell method. When you're perpendicular to the axis of rotation, you'll either be doing disc or washer based on the fact that there is a gap here, then that tells us that it's going to be washer. So we need to be familiar with the methods and what the methods require. In terms of which variable you'll be using, because this is a horizontal rectangle that's moved upward to generate the volume, then this integral is going to be in terms of y. And this is a vertical rectangle that's moved to the right to generate the volume, so this is going to be in terms of x. So we go and set up the formulas. For shell, we need the radius and the height. And for washer, we need an outer radius and an inner radius. Now there's an issue with the shell. When we get down to a point where the rectangle is below y equals 1, there's an issue with trying to find the height of the rectangle. Both the left and the right end are on the function y equals x minus 1 quantity squared. They're on the parabola, so we won't be able to find the height there. It's fine before above y equals 1, we'll be having rectangles that'll be we'll have rectangles that are in between these two functions for the height, but not down here. And so for these reasons, then shell is out and we must use washer. It's our job to find the outer radius and to find the inner radius, and then square them. So to do that, let's blow up the graph and go to another slide, and let's work out the details of setting up the method. The outer radius is a line from the axis of rotation through the region to the end of the rectangle, and the inner radius is let's do with the outer radius first. I'm sorry. So with this outer radius, we want to draw a line that goes from the axis of rotation through the region to the end of the rectangle. That distance is the outer radius. It is a difference of two distances. We have the distance from the axis of rotation all the way down to the x-axis. That distance is 4. But then we have the distance that goes up to the function, and that's your parabola. And so it's going to be 4, and then from that we subtract x minus 1 quantity squared. That's how you get the outer radius. The inner radius is where you draw a line that goes from the axis of rotation just up to the region, and that's to the beginning of the rectangle. This purple distance is the inner radius. But once again, that's a difference of two distances. The distance 4 again, minus the distance up to the line this time. And so that's going to be 4 minus the x plus 1 quantity. Let's simplify. We'll have 4 minus, when we square, we get x squared minus 2x plus 1. Applying the minus, we end up with decrease in order, minus x squared plus 2x, and then 4 take away 1 will give us a 3. That's our outer radius. For the inner radius, apply the minus. 4 minus x minus 1, simplify that to be 3 minus x. Okay, great. The one part that makes this difficult is we have to square these guys. We have to square this trinomial and then square this binomial. Let's work out the details of that before we go to deal with the integral. And the value of a is 0 and the value of b is 3. This thing moves from left to right, and you're done when you're at 3. You start at 0. Alright, squaring out the trinomial, we'll have to multiply x squared by all 3 terms here. That'll give us x to the 4th minus 2x cubed minus 3x squared. Then we'll have to multiply 2x by all 3 terms there. I'm going to draw those. I'm going to write those out on the next line, and I'm use these powers on x as columns. 2x times minus x squared is negative 2x cubed. I'll put it underneath there. 2x times 2x is positive 4x squared. And then 2x times 3 is a 6x. And then finally I need to multiply the 3 by all 3 terms on the right, giving me a negative 3x squared, giving me a positive 6x, and then a plus a 9. And then we can add these terms vertically to get x to the 4th minus 4x cubed plus 2x squared plus 12x plus 9. Great. Then we have to FOIL out 3 minus x, the inner radius squared. That's just going to give us 9 minus 6x plus x squared. And we have to subtract these two. x fourth minus 4x cubed plus 2x squared plus 12x plus 9. And from that we subtract 9 minus 6x plus x squared. We have our inner radius squared and our outer radius squared. So applying the minus, we'll have a negative 9, a positive 6x, and a negative x squared. And so combining the terms, here's what we're going to have in our integrand. X to the fourth minus 4x cubed plus x squared plus 18x, and then our 9's actually end up canceling out. So this is our integrand, inner radius squared minus outer radius squared minus inner radius squared. That's what we integrate from 0 to 3, and we multiply by pi. Don't forget to multiply by pi. And now we'll move to the third step, which is actually to perform the calculation. Okay, great. So we just find the antiderivative, no trouble, power rule in reverse, x to the fifth over 5 minus x to the fourth plus x cubed over 3 plus 9x squared. That gets evaluated from 0 to 3, and at the end we'll remember to multiply by pi. We'll put the 3 in, and what we get out is, just write it as 3 to the fifth over 5 minus 3 to the fourth, 3 cubed over 3 plus 9 times 3 squared. Upper limit, and then lower limit, when we plug that into the antiderivative, we just get 0. 3 to the fourth is 81. It happens here, minus 81, and then it happens here, plus 81. And 3 cubed is 27, but divided by 3, that's just 3 squared, so that's a 9. And then 3 to the fifth would be this 81, 3 to the fourth, times another 3, or 243. Okay, great. These 81s cancel. We have to have 243 over 5, and then we also have this 9, and so we feel that we'll find that that's 45 over 5, and that gets added. They're both positive. Okay, so we get a final answer of 288 pi over 5, whatever units you have cubed.